Hey everyone, welcome back to step 2a. In this step, we are going to focus on loading and preparing the Bedrock Geology datasets. This is the foundation for mineral prospectivity mapping because the geology layer is where all of our structural, geophysical, and geochemical data will be anchored. Where to get the data? For Ontario, the main source is OGS Earth, the Ontario Geological Survey's data portal. There you can download Bedrock Geology datasets at 1 to 250K scale. Typically, these come packaged as shapefiles. For example, here it's inside the folder called MRD127Rev1. This contains polygon geology, lines for faults and contacts, and sometimes dikes and iron formation units. In QGIS, go to layer, add vector layers, and browse to geopoly.shape. Once added, you should see the geology polygons covering the whole province. To make it readable, we also load the associated QML style file, geopoly.qml, which restores the proper symbology so units show up with the right colors. Then is reprojecting. The MDR126 shapefile like geopoly.shape are in EPSG 4269. For analysis, you want them in UTM zone 17 north to match your area of interest. So before clipping, we need to reproject. Right click on geopoly, choose expert, save feature as, and save it as a geo package in your interim folder. Setting the CRS to EPSG 26917 UTM zone 17 north. This guarantees all of our datasets share the same coordinate system. Repeat this for other shapefiles like geolines or dikes. When you reproject it, QGIS assign a default single fill color, maybe brown. The geology polygons lost the original styling. So to fix it, reapply the official OGS symbology as explained here. Your polygons will now show with OGS unit colors again. Here, our layers are not orders, so you cannot see dikes and other features. We'll do it later. We'll fix it later. Now we clip the geology to our area of interest polygon. Go to vector, geoprocessing tools, clip. Your input is geopoly 26917. Your overlay is area of interest underline AI underline 42A. Then hit the save and results in your interim folder as geology underline 48 geo package. When you add this new layer to the map, it should cover only your area of interest, not the entire province. Then you will repeat this clipping process for other datasets. For example, geolines 26917 become false underline 42A geo package. Dikes 26917 becomes dikes underline 42A geo package, and so on. And this way, every feature is trimmed neatly to your study area. Each time you reproject or clip, QGIS makes a new layer without a style. So you just need to reapply the .qml once per new output. Now your clipped geology will look like the provincial map, but cropped to 42A. Here, as you can see, dikes and structures like faults are hidden behind geology, and this is because layer ordering. So we need to fix the drawing order. For example, you can now here you can drag the dikes underline 42A layer above geology underline 42A in this panel, in the layer panel. so they are visible on the top. Then set their symbology to a bright color like red, so they stand out against the background geology. The order in the layer panel is the order QGIS uses to draw them on the map. At this stage, you now have a clipped style geology dataset that matches your area of interest. And this is your first major input for mineral prospectivity mapping. From here, we'll move on to faults, mineral occurrences, DEMs, and geophysics. But everything will now align with this geological framework.